y'all, welcome to Miss Clarke's chemistry class. In this lesson, we're going to talk about how to tell the difference between a polar molecule and a nonpolar molecule, but we're going to do it in a little bit of a different way. I'm going to show you some examples of polar molecules, then I'm going to show you some examples of nonpolar molecules, then I'm going to show you mixtures. And I'm hoping that after you observe the differences between polar and nonpolar, you can sort the mixed molecules all on your own with me not actually teaching you very much except for just showing you the different shapes. So grab your notes. If you have a lab paper, go ahead and grab that and let's get started. Okay, so first we're going to start with nonpolar molecules. So let's look at some nonpolar molecules. Now let me back up just a tiny bit. I'm talking about the molecule as a whole, polar and nonpolar. That's not the same thing as a polar bond and a nonpolar bond. Remember, polar and nonpolar bonds, that's covalent bonds where we're sharing electrons. A polar bond means we're not sharing those electrons very evenly. When you have a polar bond, you've got two atoms bonded together because they're sharing electrons. But sometimes that sharing is not very equal. Sometimes one atom is going to be more electronegative. It's going to pull electrons closer to it. Nonpolar bonds mean they're about the same electronegativity. Their pull for electrons is about the same. And so they share more equally. They share their electrons more equally. That's polar and nonpolar bonds. I'm talking about molecules. How does the total molecule feel? Because you can have a nonpolar molecule even though every bond is polar. So let's look at these shapes and let's see if you can notice the difference. Okay, so first I'm going to look at some nonpolar molecules. Every one of these are nonpolar. Now let's talk about this model. We've got a central atom, and then we have sticks to represent the bonds. We can have sticks or springs. In this model, we have sticks. The other color represents a different atom. So we've got this gray atom, and then we have three white atoms, nonpolar. Again, another nonpolar. We've got an atom, and then we've got atoms. We got four atoms bonded to this atom. Again, still nonpolar. Now this spring, this is a double bond here. But let's talk about these sticks right here that do not have atoms on the end. These are lone pairs. So there's a lone pair, lone pair, lone pair, lone pair. Again, nonpolar. And then here's my last nonpolar molecule. Press pause, sketch some of these, so you might have to rewind back. I also want you to notice a few things. The whole idea of this is for you to come up with your own set of rules so you can decide between polar molecules and nonpolar molecules. So we're developing a set of rules. Keep that in mind as you are writing the descriptions down for these nonpolar molecules. So go ahead and pause, write those few things down, and then meet me back in a second and let's look at some polar molecules. Okay, we're back. We're ready to look at some polar molecules. Again, remember, you're trying to figure out the difference and you're trying to come up with your own set of rules to figure out the difference between polar and nonpolar. Now, it might have been hard to describe nonpolar because you didn't have anything to compare it to. When you get through looking at these polar molecules, I'm hoping that you're going to start noticing some subtle differences. So let's look at this first polar molecule. Again, we've got this central atom, three atoms bonded to it, and this is a lone pair. Don't forget that this stick is a lone pair. Polar molecule. Another polar molecule. We've got two central atoms, we've got three of the same atom, and we've got a different atom. That's why I'm saying it might be good for you to write these down and draw these using colored pencils or colored markers or something. Polar. Here's another polar. Remember this double bond. Here's another polar molecule. And then my last polar molecule. Pause this lesson, draw a few of these polar molecules. So you might have to rewind and push pause so you can draw these. Again, it would be to your best interest if you were using colored pencils or colored markers so you could show the different atoms. So spend a little bit more time making some observations because, again, you're trying to come up with a set of rules. Meet me back in a second. I'm going to show you mixed molecules and you're going to see if you can tell the difference between polar and nonpolar. Okay, you've got your rules in front of you. You think you've got it figured out, the difference between polar and nonpolar? Let's see. Here's your first molecule. Is this polar or nonpolar? Here's your second one. Polar or nonpolar? Here's your third one. Polar or nonpolar? Here's your next one. This is fourth. Again, polar or nonpolar. I got two more. And then last one. If I went too fast, pause, rewind. I want you to label all of these as polar or nonpolar. Now, I know I'm putting a lot of trust in you to do this. You could just keep playing and let me tell you all the answers. But let me tell you, that's not helping you at all. You're here because you're trying to figure this out. If you listen and follow through with what I'm asking you to do, you're going to learn this better. And for some reason, this is a concept that's often very confusing. I have found when you can kind of figure it out on your own that you do much, much better. So if you need to pause and take a little bit more time, do that. Do not keep going until you're ready for an explanation. Okay, here we are back with the explanation. This first molecule was nonpolar. I like to think about polar and nonpolar as symmetry. So even if these two molecules were very electronegative and they're pulling the electrons towards it, they're going to equal out. It's like playing tug of war. And if this guy and this guy are the same atom, they're pulling with the same strength. No one's going to win tug of war. And when no one wins tug of war, that's nonpolar. The same thing with this one, to tell you the truth. This is nonpolar for the exact same reason. We've got all these lone pairs, but it's equal on both sides. So if we were going to play tug of war, no one's going to win because everyone's pulling with the same strength. No winning tug of war, nonpolar molecule. The third one we looked at, this is a bent molecule, bent with these two lone pairs. So they take up space, but they don't pull. The atoms are the only ones that's pulling. So these two atoms are pulling one direction. These lone pairs can't pull. Someone is going to win tug of war. And when someone wins tug of war, that's a polar molecule. These extra lone pair is what is making this molecule not symmetric or asymmetric. I know you're thinking, Miss Clarke, couldn't you just cut it in half like here? Make sure I'm getting this on camera correctly. Right here. And you could fold it and that's not exactly how atoms work. It's all about all the way around that central atom. This is polar. Our next molecule, now linear, like our first molecule was linear. Linear is often nonpolar. But here we've got two different atoms with two different electronegativities, with two different pulling strengths. If these two atoms play tug of war, someone will win. Polar molecule. And it's because they're different on either ends. Here was our next molecule. This was a tetrahedral. Now this is also nonpolar because we've got the same type of atom bonded all the way around the central atom. If they were all to pull equally, and they will because they're the same type of atom, no one's going to win tug of war. Symmetry because all of the atoms are the same all the way around. Let's look at this molecule. We've got trigonal pyramidal. Trigonal pyramidal has this lone pair. This is asymmetrical. If we're playing tug of war, these white atoms are pulling. These lone pairs can't pull. Someone's winning tug of war. This is a polar molecule. You know what? I want to show you one more example that was not in this sampling of polar and nonpolar, just to drive home one last fact. This molecule was also tetrahedral, but it is polar. It's polar because of this different atom here. It's going to be pulling with a different strength. Now, I'm not sure what these atoms are because they're just colored balls. But they're going to have different electronegativity. So the orange is going to pull with one strength, green's going to pull with a different strength. Someone's winning tug of war polar molecule. Another example, that it looks symmetrical, all except this different atom here. I think it's easiest if we've got different atoms around the central atom, like this one or this one, that's going to show polar. Or if you have lone pairs on just one side of the molecule, also going to be polar. The only time you're going to have lone pairs and it's going to be nonpolar is if they're symmetrical all the way around. Well, I really hope that helped you to be able to tell the difference between polar molecules and nonpolar molecules. If you're needing more help with polar bonds and nonpolar bonds, I do have a lesson on that. Check out that link up above. Until next time, bye y'all.